Note the terms class C is used in this document to help facilitate the understanding of the IP addressing and subnetting. IP address class terminology is rarely used in the industry anymore because the induction of classless interdomain routing, or it is called CIDR. Anyway, please try to remind the things that we have done last time, because we have started the subnetting and we have done 2 examples. So by the way, sometimes since we could not meet 2 weeks, sometimes you may have forgotten. So better to refresh the knowledge that we have gained during the last before 2 weeks ago, the knowledge. So therefore, please do this example, right? So I'll give a few minutes. So please try it, and we will see that how to resolve this problem, right? Any questions to start before? Before resolve the problem. Any doubts in the question? If you have any doubt, please ask, right? Those who have joined recently, so you can go through the question. So please try by yourself. And here, of course, I can give some clues. First of all, you have to use the 2 formulas that we have learned so far. That is, if you want to determine the number of subnets for a particular network, you can use 2 to the power n formula. The n means the number of bits that you have to borrow from the hot side. So here, of course, you can see according to the net mask, it is belongs to class C. That is the prefix length is 24, So then everybody knows that only 8 bits remaining for subnet as well as the host side. So therefore, so according to the question, they ask 5 subnets. So you have to think like this way. If I borrow 1 bit, I can make 2 subnets. If I borrow 2 bits, I can only make 4 subnets. If I borrow 3 bits only, I will able to satisfy this 5 subnet requirement. So therefore, if you like or not, so you have to borrow 3 bits. So that means exactly you can't make 5 subnets, but you have to have an extra one also. So that's why it says that list the extra ones too, right, in the question. So therefore, the n 2 to the power n and the n is equal to 3. That means the number of bits that you're going to borrow from host side. So 2 to the power n is become 2 to the power 3 because the n equal to 3. And then it's that is 2 to the power 3 means that is 8. So that means you can make 8 subnets. So similarly, now you know that already you have borrowed 3 bits from the host side. Because of that, the host side has only 5 bits because the whole octet has 8 bits. Already you have borrowed 3 bits for the subnet representation. So therefore, remaining 5 bits you can utilize for host IP addresses. Now you can see how many addresses you can make, host addresses you can make from these 5 bits. So in order to calculate the number of host addresses that you can make here, so you can utilize the formula that we have learned, that is 2 to the power n minus 2. So n is equal to 5. That means 2 to the power 5 means 32. So when you deduct 2 from this 32, then it's become 30. So that means you can make 30 host IP addresses for each 8 subnets that you are going to make here. So that means the requirement has been satisfied because they are asking only 25 address for 25 computers for in each subnet. So therefore you can satisfy the requirement. So accordingly, you have to determine what is the net mask of this particular subnetted network. If you are going to utilize 3 bits for representation of subnet, so you have to get the decimal value of this 3 bits, which is representing the net subnet ID also, right? So that's also belong to the net mask. Then you can write the first subnet IP address and the host IP address ranges and the broadcast address, right? So that is what I can give you as a clue. So try, keep on try. So 1 or 2 minutes I'll give another. If somebody has not identified how to resolve this problem, so then think a little, and then after that I'll show you how to resolve it. Okay, so don't wait for me, so you try yourself. So first you can, if you have found yes, correct. The Lahiru, correct. That is the prefix now is 27. Why? Because you have borrowed 3 bits for subnetting. So therefore now the extended network prefix is 27. So therefore hereafter when you are writing the subnets IP addresses, you can write in CIDR notation /27, right? Now it is not 24 because already you have got the borrowed the 3 bits from host side, and now it is belongs to the network ID, right? So anybody who found the net mask of this subnetted network? So you can type in the chat box so I can see whether it is correct or not. Shall I get the attendance? There, along with me, there are 49, so that means 48 students with me now, right? So I'm taking the attendance. What I can do is I can download the attendance for our Excel sheet. So that's what I do. So if the London Tech asks from me, so I can provide them the attendance, right? There's no any other things, all right? So while you are trying, since the time is flying, I think better to show you how to resolve the problem. So let's see. So you try yourself. So while you are trying, I'll show the way that I'm resolving it. Now look at. So I believe that you can see my Excel sheet. So right. So here you can see the IP address I have typed here, and the net mask also I have here. So, and I have got the number of subnets I can make here, 8, and number of hosts for each subnet I have calculated here, right? So the requirement is 5, but you have to you can make 8. Requirements is 25, but you can make 30. So this is how. And these are the 4 octets that we are going to utilize for this question. And by converting this 192, I have written the binary pattern, and 168 I have written the binary pattern. 162 I have written the binary pattern, and the host side, which is remaining 8 bits, right? So that is how I have used this Excel sheet. So this is the net mask 255, 255, 2550, right? So I take this octet to represent the 8 subnets. You can see that initially the borrowed 3 bits are in 0 state. Then I increment the rightmost bit by 1. So then likewise I am going to recognize the all possible patterns that I can make by these 3 bits, right? So these are the 8 subnet bit patterns, and these are the subnets network addresses which I have found accordingly, right? So you can see that it has been incremented by 32. Here also 32. Here also 32. Why? Because the incremental bit is the decimal value is 32. So therefore, it's always incrementing by 32. So similarly, when we get in the decimal value also, it is increasing by 32. So it is 224. So therefore, the subnet that they ask is here 2 to 4 after subnetting, right? After subnetting, it's become 2 to 4. Why? Because already we have borrowed 3 bits for subnetting. So that's also belong to the net mask. So I think it is understood by you, right? So now if I go further, so I consider the first subnet. So we know that when we increase the host side bit by 1, so that is the first IP address 192.168.162.1, and the last IP address is all these bits, that is 16, 8, 4, 2, all are become 1, and only the last bit, the 2 to the power 0 bit, is always remaining 0. So that is the last first IP address that we can make. So when it comes to the broadcast address, all these blue color 0 bits become 1. So that is the bit pattern that we are going to use for the broadcast address. So that is the broadcast address is 192.168.162.31. So that means before this address, the last address should be then this one, that is 192.168.162.30. So then we can determine the next IP address of the next subnet. So it should be definitely 32Y. So the broadcasting address here 31. So this is should be 32, and the first host IP address should be 33. And if the broadcast address is 63, so then definitely the last IP address should be 62. So if this is 63, so then we know that the subnet should be 64, and the first starting IP address is 65, and the broadcast address should be 95, and the last should be 94, right? If you want to find the broadcast address of this range, so from here you can also determine why, because it should be less than 1, that is 95. Okay, so likewise you can find out the other host address ranges as well as the broadcast address of these addresses, and you can fill the questions chart that has been given in the question, right? So if any doubts you have, so please ask from me. So here actually what I did was I was found this binary patterns because I know that if you want to make 192, definitely I have to switch on 128. Why? Because the maximum decimal value that I can deduct from 192 is 128, and it will remain 64. So that 64, if you want, so this is the maximum value that I can switch on. So then 128 plus 64 means 192. It is correct. So therefore this bit pattern is correct. So likewise, the other bit pattern also I have found like this. So that's why I have written this decimal values ranges like this according to the 2 to the power value, right? So that's also it's clear for you. So by writing like this in Excel sheet, so it is easy for you to understand how these values are comes, and you will not make any mistakes, right? So that is how it should be, right? So if you have any doubts, please let me know. So, so therefore, if you have any doubts here, you can ask from me. So these are the possible values that can comes to the subnets as well as host IP ranges, right? So you can fill out the remaining ones here. I'll fill the one set. So the last IP address is that is the subnet IP address is 96. So therefore it should be 192.168.162.97, and the last IP should be, so here the 128 is the next subnet IP address. So here you can write the broadcast address as 192.168.162.127, right? That is the broadcast address. And so there you can write the other range 192.168.162. So it should be 126, right? So that is the IP range which should come to this particular subnet. Okay. So any question, please? Or can you understand? Are you all right with this solution? Any doubts? Yes. Any doubt, please? My confidence. So when you are configuring a network with subnetting, so you should know these things because you have to provide IP addresses for different networks in different ranges. And so it will be provide the manageability, easy manageability and efficient manageability of network. And you can put controls, access controls to different networks by assigning different IP ranges according to your requirements, right? So this is the one of the requirement to doing subnetting and divide the large network into small portions, so to increase the manageability of your entire network. So as a network engineer or a network administrator, you have to face these problems, and you have to decide, and you have to design, and you have to plan IP addressing schemes for different purposes when you are handling a network in your organization. So therefore, don't touch on the surface. Please thoroughly try to understand how you should do this theoretically. And then of course you know what is really happening when the troubles comes, right? So otherwise you will not be able to do the troubleshooting if you don't know the theory behind this, right? So that's why this is important to learn how these things are happening and how these subnetting values are coming. All these things should be you should know by yourself without any electronic aid, because sometimes if a particular mistake has been happened, so if you don't know the theory behind this, so sometimes you will not be able to understand what is the real problem inside this, right? So that's why the theory is very important to know, right?
Hello, sir.
Yes.
Uh, Sir, I have just a little doubt. I just
Yeah.
need to clarify. So,
Hmm.
since we have private IP addresses from the 10 range and A class and B class, why we want to use the class C and we have to do the subnetting? So easily we can use the 10 ranges and keep the this allocation a little bit high, right? So what is the requirement of we have to choose the class C and to make the subnetting?
Actually, I don't agree that if somebody says that it should be class C, that according to the requirement, it's depend, right? Because sometimes you may have seen that most of the time the teaching the class C addresses are taking as examples, but not like that, because according to the size of the network, sometimes the class C address is not enough. You have to take class B address also. But as you said that if a particular range has been reserved for a particular purpose, so then you can't use those ranges, because it will be problematic in the future. So that's why we eliminate those ranges and customize our ranges according to our requirements. But anyway, there is no any problem if you take class A address and do the subnetting, and if you take class B address and do the subnetting. If you take those two classes addresses for subnetting, it's not a matter. That is depend on your requirement, right? If you have a big network, so then you have to take the class B address from ISP or class A address from ISP, and then you have to do the subnetting accordingly. So there is no restriction of getting other classes IP addresses. But if there is any private ranges which are being um, reserved for certain purposes, so then you have to ignore them. I mean, we have to omit them, those ranges, and we have to use a particular customized range for your purpose. Are you satisfied with that answer?
Yes, sir. Okay, thank
No.
you, sir.
No.
Sir, can you hear me? Excuse me, sir.
Yes,
Can you hear
please.
me? Yeah.
Yes, I can hear you. Yes.
Yes, sir.
Please
The
ask the
normal,
question.
yeah, the class C normally it's a private range, right? The IP address, it's a
No.
private type.
Uh, Actually, most of the time people are used to use class C. That's why it is very popular, right, among
Yeah.
in the industry. But that is not any other theoretical reason for that. But people are tend to, because its handling is very easy, and also most of the time when you take organization, sometimes you can satisfy with the class C address when doing subnetting. Why? Because the number of hosts that you are occupying in a network is very small, and sometimes it's less than 200 or less than 250. So because of that, most of the time people tend to use class C address. But as I said earlier also, there is no any restriction to use class B and class A addresses so for any organization. So actually, in other countries, you can find, because because multinational companies, big companies, sometimes they have a large network which is subnetted for different departments and divisions. So there they use class B and class A addresses as well.
So what is the benefit of submitting? Mean like a different devices or something we can use that one it will make easy and
There are different types of subnetting, right? Sometimes it is based on devices, right? Sometimes it's based on division. Sometimes it's based on organizational units. So that is depends according to the requirement of the organization. So
the subnetting, it's help to reduce the network traffic, do you think?
yes, actually, it's create separate broadcast domains, right?
Okay,
So
so it
because
will
of
be
that, sorry. Hello. Yes, you can tell me. Hello, Alim.
Yeah, can you hear me, sir, now?
Yes, I can hear you. Yes, please.
Yeah. So in one LAN network, there is a example. We'll tell like a 50 computers in the same network. They're using like around another or around 100 CCTV cameras, the IP cameras.
Yes.
And then another devices as well. That like a micros, like a cash register, like a many devices are there. Even the access controls as well.
Yes.
So that means it will be easy to manage for them because they can categorize like a different subnetting for like computers, different for CCTV cameras, and different for the access control as well, something like that.
Yes, yes, really, yes, because it is somehow it is contribute to the security also in the network, and also you can use not only the fixed length subnetting, you can use variable length subnetting also, as you said. Now here
So
actually we are discussing about fixed length, but as you said, according to requirement, it can be use variable length subnet mask also for subnetting.
okay, so that means it will be not giving some like a conflict or anything between the computer network and CCTV, and it will be run on their own paths, right? Those
That's right.
devices.
Really.
Okay.
And also when you give the QoS configuration, access control, ACL, access control list. So all these things are very convenient, right?
Okay.
No
Thank you very
confusion.
much, sir. Thank you,
Yes.
sir. Thank you.
Okay.
So one more question, please.
Yes.
So if we are going to choose the 10 range, the host part will be very high, right? Is
Yes.
there is any drawback? Is there if we are going to select 10 range a class for our company or any institute? Is there is any drawback? Is there, as I asked before also,
Yes,
rather than
there is a
choosing a
drawback.
class C?
Yes, according to the scenario, it is become a drawback, right? Why? Because if you have chosen 10 range, but you have more than 24 bits, I mean, actually 24 bits are available for host side, right? As you said. So 2 to the power 24 means a big number of address, right? So if you are not utilizing those addresses, uh, for your requirement, so then you are wasting the IP addresses within your organization without utilizing for any purposes, and also it will be vulnerable to certain security issues also, right? So that is one of the concern that if you don't need that much of IP addresses, so why should go for that kind of risk or vulnerability explore to your account network? So that is what behind that decision.
Okay, like I asked before, if we can choose the 10 range, we don't want to do the subnetting, right? So that's why I was just asking. So rather than subnetting, we can use separate IP address for the separate departments in the
Yes.
10 range.
Yes.
So that's only the drawback we have, the vulnerability, right? So that's how
And also
we
the
have to.
manageability also not good, no? Because you think that you have a large network and it is occupying large number of devices. Sometimes you can remember even, and also if you're going to assign certain controls and everything, very difficult to handle it, right? But if you have categorized it and classified, so in such a situation environment, the identification, managing, and controlling everything is easy, no? So that's why people tend to go low ranges than large ranges of host site.
Okay. Okay, sir. Thank you very much, sir.
Yes, but you can't say that you can't go for a 10 range. Why? Because if you have a requirement like that, so you have to go for that. Though there are some disadvantages, you have to go if you want. But that is depend on, as I said, Alim, he said that some of the divisions they have 100, some of the divisions they have 50. So then the most suitable one is the variable length subnetting.
Oh, okay, sir. Because I was asking, because in my company they are using the 10 range. I don't know even why they are using the 10 range. So that's why I was just asking.
Is it a large company?
Not a large company. Even we don't have that much of devices as well. But I don't know why the network guy has chosen the 10 range.
But you can change it.
Yeah, but I don't have any access. Okay.
No, I mean, if one of the engineer is your friend, you can ask from him that why you are utilizing this much of ranges and why don't you go for a low range than going for a high range? And you can suggest that him why don't you go for this? And sometimes I don't know, some of the requirements are there for routing and switching. Better to ask from him that why he's keeping the 10 range of these, I mean, these IP ranges. So sometimes it might be like that, right?
Yeah. Okay, sir. Okay, thank you.
Yeah. Any other questions? Thank you for asking questions, right? Because it will benefit to the others also, those who are not asking questions, right? So any other question if you have, you can ask, right? No problem.
Sir, gateway එකට අපිට use කරන්න පුළුවන්ද? use කරන්න host IP range එකකින්මද?
gateway එකට ඔයා කියන්නේ network එකකින් එළියට යන්න. ඒ කියන්නේ ඉන්ටර්නෙට් එක පැත්තට යන්න වගේ.
router එක gateway එකක් අපි IP address ගන්න gateway IP එකක් දෙන්න ඕනනේ.
ඔව්.
device එකට දෙනකොට.
ඔව්.
gateway IP එකක් දෙන්නේ host IP range එකෙන්මද මේ broadcast IP එක subnet
නෑ වෙන range එකක දෙන්න. වෙන එකක දෙන්න පුළුවන්.
idea එකක්.
වෙන එකක දෙන්න පුළුවන්. මොකද ඒක සාමාන්‍යයෙන් config කරන IP එකක් නේ. gateway එක කියන්නේ. එතකොට ඔයාට ඒකට වෙනම gateway එකට IP එකක් දෙන්න තැනක් තියෙනවා. එතකොට ඒක මොන range එකේ දුන්නත් ප්‍රශ්නයක් නෑ. යා network එකකින් එළියට යන්න යනකොට ඒ gateway එක පාවිච්චි කරනවා.
එතකොට අපිට මේ range අපිට දැන් කිහිපයක් කියන්නේ පිටම branches වගේ තියෙන තැනකදී මේ ඒ branch එකේ අපි තුන් PC කිහිපයක් 5ක් 10ක් use කරත් අපිට branches දෙක තුනකදී මේ range වෙන වෙනම use කරන එක හොඳ. ඒක security purpose එකට හෝ.
ඔව්. ඇත්තටම ranges පාවිච්චි කරන එක තමයි හොඳ. මොකද්ද හිතන්න එක branch එකකට මොන හරි restriction එකක් දාන්න ඕනි කියලා. එතකොට ඔයාට මේ ඒ different ranges තියෙන එක ඔයාට පහසුවක් වෙනවා. මොකද ඒක එතකොට අනිත් branches වලට මේ effect එකක් නැහැ, impact එකක් නැහැ. අනිත් එක තමයි ඔයාට branch එක identify කරගන්න ලේසි. හිතන්න මොකක් හරි ගැටලුවක් ඇති වුණා කියලා branch එකකින්. එතකොට මේ මොන range එකේ IP එකකින්ද මේක කරලා තියෙන්නේ කියලා හොයනකොට ටක් ගාලා branch එකක් අහු වෙනවා.
හරි.
Hello sir. Normally අපි gateway එක normally අපි config කරන්නේ සාමාන්‍ය same config කරන range එකෙමද sir? Normally එහෙම නේද දැන් යන scenario එක තියෙන්නේ. අපි හිතමු.
ඔව් ඉතින් මේව මතක තියාගන්න ලේසි නිසා සමහරව ඒ range එකේම එකක් දානවා. නමුත්
separate wheel එකම මේ company එකේ separate VLANs තියෙනවා නම් අපි සාමාන්‍ය එකම range එකේ මේ gateway එකක් තමයි use කරන්නේ.
යූස් කරන්නේ මොකද මතක තියාගන්න සහ මේ ඒක රෙකෝඩ් කරලා තියාගන්නකොට ඒක පහසුයිනේ අනිත් තව කෙනෙකුට ඔක බලන්නකොට. නමුත් ඒ වුණාට වෙන එකක් දැම්මයි කියලා ඉෂුව එකක් නැහැ. මොකද අපි වෙනම මේක assign කරන නිසා. කියන්නේ ගේට් එකක් අපි assign කරනවානේ අනිවාර්යයෙන්ම මෙන්න මේ ගේට් එකෙන් යන්න කියලා.
මැපින් වලටයි ඩෙන්ටිෆිකේෂන් එකටයි බලපුවම අරක ලේසි සේම් රේන්ජ් එකෙන් දෙන එක නේද?
දෙන එක. ඔව්. ඇත්තටම පහසුවට තමයි මේ එකම මේකේ IP එකක් දාගන්නේ.
right.
Any other questions? Yes. All right. Any question with the subnettings? No issue. Okay. So we'll try another one and we'll finish it off, right? So I'll share the document again, and I'll show you the answers for the things that we have done so far. So you can, if you have done this one, so you can correct it if you have made any mistakes, right? I'll show you the answer. And the complete answer, right? This is the complete answer, right? So you can see if you have made any mistakes in your answer, so you can correct them. Okay. All right. So if you like, we can do another example. That is example 2 also. So then we can finish off by this one. And, right. So this is another one, right? So you can try out this one. So I'll give you 5 minutes. So it's a company ABC would like to subnet its network. So the IP has been given, so that there are 32 separate subnets. They will need 6 hosts in each subnet and complete the following table. So because there are so many subnets, don't write them all out because you know that there are 32, right? So you can't write all the 32. They will need 6 hosts in each subnet and complete the table. So unless you just want to, if you can do the first 10 and know what the last one is, so then you got to get the idea, right? So then you find 10 and then after that the last one. So they're asking only the 30-second subnet, right? All right. So this is the question. So you can see another one. So this also can try. That is example 3. Right. This also can try. Right. So then we finish off that submitting part. So if you look at the answers, we can see that for the second one, the second question is this one. So I'll show you the answers. That is right. We can see that it has been borrowed 32. It has been borrowed 2 to the power 5, that is 32. 5 bits has been borrowed from host side to represent 32 subnets, and only 3 bits are remaining for the host side. Right, so therefore the subnet mask has become 248 because 5 bits have been utilized for that. So how this 248 is coming? 128 is there, 64 is there, then 32 is there, and 16 is there. So altogether, if you calculate it, you can get this value 128, 64, and 32 plus 16. And open Excel sheet, and you can get the value of those so then we'll get end up with this right. So that's how this count, right? Check the values, right? 1 to 80 should be there, 64 should be there, 32 should be there, 16 should be there, 8 should be there. So all these strings, if you add together, so then you get 248, right? So that is how this value has come. So then you know how this came, because they have utilized 5 bits from the host side for the representation of 32 subnets. So others are the ranges of host addresses and broadcast addresses. Right. So the third question. Yes. Third example. They have to 50 separate subnets, and they'll need only 2 hosts in each subnet, right? So they have to utilize 6 bits. 2 to the power 6 means 64. So they like or not, they have to utilize that. So and then only 2 bits are remaining for the hosts. Okay. So then 2 bits means 2 bits, 2 addresses will be 80. 2 bits mean 2 to the power 2 means 4. That means 4 addresses they can make, but 2 addresses only they can utilize, because another 2 address will be utilized for broadcast, represent the broadcasting address and the network identification address. So therefore, when they deduct it from 4 they deduct 2, then the 2 is remaining. So that means they can utilize only 2 IP addresses. So that's why this changes came, right? So therefore, the net mask is became 252 because they have borrowed 6 bits from the host side. So this is how it's happened, right? So I believe that it is understood. Right. So here, how many subnets are actually created this subnet? So that is 64, right? That's the title. Okay. So I think you got some idea, a clear idea about it, and then I'll utilize some slide so that how this variable length subnet mask is utilizing. So there I will show you some example. So this is one of the network topology diagram. I'm showing you as an example. So here you can see that there are different sites and their requirements for the host IP addresses are different. So because of that, they have utilized different IP addresses. I'll show you that here. So then the subnet mask is the net mask or the extended net prefix is different, right? Here 28, here 27, here 30. So likewise, according to the requirement of the IP addresses, they have varied network prefix accordingly to avoid the wasting of IP addresses without utilizing. So this is called variable length subnet masking, right? So that's how the varied customized extended network prefix have been utilized to customize the requirement of the network. So because if you look at the requirement, you can see the number of hosts that they want is different number of hosts they need in this network topology diagram. Okay. So that is one of the things I want to highlight. And if you need more exercises to do by yourself, so I will go to the chat and type, right, some of the sites. Yes, I will share my Excel sheet also. Don't worry, right? Everything I will share. And please go to these sites, right? www. Netting. Please Google these sites, right? And the other site is www.subnetting.org. Very good sites to practice subnetting. And also, if you are doing it in a professional level, and if you want to quickly do it, so you go to the site IP subnetting calculator, right? And Google it. So then you can find a IP subnetting calculator. By using this calculator, also you can straight away get the results that we have done manually, right? So that it will be more convenient for you to do, right? These are some of the options that are available to minimize your time and do it in a fast way and keep the accuracy to the 100%. So these tools you can use for submitting, right? So please refer the chat box. So I have typed and sent it to you. So then you can refer those sites and you can practice. Okay. So then I'll try to start IP version 6. Before we jump to the IP version 6, we look at why we need IP version 6, right? So therefore, I'll go to my last basic it. So then I'll able to explain you why this IPv4 is not need. I mean, why they have gone for another IP version rather than restricting to a IP version 4. So let's see, right? I'll show you the slide. So you can see that the disadvantages of IPv4. This address space is not enough. Actually, we know that nearly 4 billion addresses we can make out of this, and it has very huge network routing tables, right? Difficult to configure and security optional, because actually IPsec like security features are not available in IPv4 like IPv6. So therefore, there was a requirement for address space as well as for security, as well as for configuration requirements. A new solution, new IP version, which is provide this solution. It is plenty of addresses, simplified internet routing tables, easy and automated configuration, and security is required. That means IPsec like features, right? So those are some of the advantages of using IPv6. So I have a question to ask that this is the plenty of addresses, right? 3.4 into 10 to the power 38, right? Because it is a 128-bit address, so therefore it has a large address space. You can see that how many bits are there? 128 bits long address. So display in 16-bit hexadecimal blocks, right? So if you want to represent the IP version 6 address, you are using 8 blocks, right? And you can simplify it by using different roles, right? That means one rule is we can omit leading zeros, and we can represent the consecutive zero groups by double colon. So likewise, some rules we are using to compress the address or to simplify the address, right? So therefore easy to configure because of this characteristic. And some of the other features also there. And also there are different types of IP version 6 addresses. That is unicast, multicast, and anycast. Now here you can't find like in IPv4 the broadcast. Instead of broadcast, you can find anycast. Anycast means one to one of many, right? So in unicast, if you look at one-to-one communication, there are 3 types of addresses. That is global addresses and link local addresses and unique local addresses. Multicast as same as in IPv4, and it is communicating with one to many, right? And some of the other important details that link local address, if you take, it is always starting from FE80. And unique local address you can recognize that is always starting from FC or FD. And also if you take global address, there's a global prefix. It's most of the time it is starting from 2 XXXX or 3XXXX or any number. Always it is beginning from 2 or 3. So it's global address, right? And these are some of the few features. But anyway, my question is, which I was trying to ask. So why was this IP version 6 got much time to come to the field? Because it was found, I think, somewhere in 2000 or 1996. But it came very lately to the field. So what is the reason for that? So can anybody tell me? So what is the real reason for taking much time to get back to the to the networking field after IPv4? So what is the main reason for that? Anybody can explain why this IPv4 to IPv6 migration taken long time? Yes, anyone can answer? Yes, good. With device support was not there for IPv6 is sometimes one of the reason. Actually, when we take in the sense that why these devices are not supporting any device, if you take it is running with a software, right? So these restrictions are coming with the most of the time applications. You know that most of the application are written to the socket. So what do you mean by socket? Yes. What do you mean by socket? Now in networking programming, we use this. Or when you're writing an application, we write the application to the socket. So otherwise, most of the devices will not support. So, and also the device recognition also not can be done, right? So you will not be able to recognize the device that a particular person is using if the application is not written to the socket. So what is the socket mean? Socket means IP address plus port number, because most of the application are written like that. So early days, that means somewhere in 1990s, the most of the application were written to the IPv4 IP address plus port number. So because of that, in a drastical change, the users might get problems, right? So if somebody going to change it at once application, so it cannot be do like that. Once you can't change application, it will take considerable time. So that was the migration period that has been taken for long to migrate from IPv4 to IPv6. So therefore, most of the application like popular application like Facebook also got much time to convert from IPv4 to IPv6. So then after that, they were started to support. So that is the main reason for getting long migration time from IPv4 to IPv6 is it because the dependency of application on the socket or the IP address plus port number, right? So I will jump into the history of IP version 6. So better to reveal it to you. See that if you can see my slides, the IP version 4 is proven itself at a robust troubleshooter testing protocol and has served human being for decades on its best effort delivery mechanism. But it was designed in early 90s and did not get any major change afterward. So that at that time of its birth, the internet was limited only to a few universities for their research and to Department of Defense, right? So that's why the IPv4 is 32-bit long, which offers around 4 billion, nearly 4 billion addresses. So this address space was considered more than enough that time. But later on, what's happened? The major points which played a key role in birth of IP version 6, right? The internet has grown exponentially and the address space allowed by IPv4 is saturated. So there is a requirement of protocol which can satisfy the need of further internet address, which are expected to grow in an unexpected manner. So therefore, the people wanted a universal numbering address, which is supported for particular person. He can have 7.7 billion addresses, right? So that is a big address space, right? You can give addresses to your fridge, your TV, your pet, your microwave oven, everything can have a IP address, and it will be more helpful to implement Internet of Things like technology, right? And the features like network address translation like technology. So these were discouraged because of this finding. And IP version 4. There's a problem with the power, I think. Now it's okay. Now you can hear me, I think, in my slides also. So therefore, as we discussed just a moment ago, the data has to be encrypted with some other security application for being sent on internet. So those are some of the drawbacks which we were discussing earlier also. And the IP version 4 enable clients can be configured manually, and they need some address configuration mechanisms. So therefore, the no technique which can configure this device to have a globally unique IP addresses, right? So those requirements were there. So, but there was another intermediate IP version, that is IP version 5. But it was in experimental level and it was not came out to the field, and it was override by the IP version 6. And then that the IP versions and their use is there in this table. You can see the different IP versions, and that is for your information. And this is the brief history of IP version 6. That taking the free recognitions of the situation that might arise, the Internet Engineering Task Force in 1994 initiated the development of an addressing protocol to replace the IP version 4. So that much early it was started, and the progress of IP version 6 can be tracked by means of RFC published, right? So these are some of the RFCs that you can use, request for comments. So if somebody is interested to study about the IP version 6 very deeply for as and research, so then they can utilize these RFCs for their research, and you can get more information on that, especially if you are interested in IP version 6, that is RFC 4291 and RFC 3775 is the most appropriate, and also the 3315 is a very good request for comments, because whenever the scientists have found something and they will open their findings to the public. So this is how they open their findings to the public, through request for comments document, right? So that's why I have brought it for your attention. And the large address space, that is one of the feature of IP version 6, and simplified header, it's another feature, and end-to-end connectivity. So therefore, unique addresses can be make use for anybody, and the auto configuration capability, fast forwarding and routing capabilities, IPsec, that is security, encryption ability, and there's no any broadcast. So because of that, the traffic also can be minimized within a network by avoiding the broadcasting. And it is using a new feature called Anycast support. So that is also a good feature. And mobility, because you can have a unique IP address wherever you travel around the world. So the same IP you can use, and enhance the priority support, and the smooth transitions, and extendability, because you can add more headers to the packet header, and you can forward the information to the destination by adding more headers to the initial packet. So those are some of the features, and this is the address scope for IP version 6: link local, unique local, and global. So that is one-to-one communication, and multicast and anycast also they are in addition to this, right? This is unicast, multicast, and anycast, right? So these are some of the types of formats. This is the address block. So it has been given an example, and these are the two rules that we use to compress the IP address when we are using it in a normal life. You can see that the block 5 has 0063. So the leading 2 zeros can be omitted, such as in the 5th block. So then we can write it like 2001 colon 0003238 DF E1, and omitting the leading zeros, we can write 63 and 00000, right? So if you want to do more compression, actually you can remove these leading zeros also, and we can represent these zero blocks with a single zero. And also there's another rule, that is the second rule. Second rule says that if you have more consecutive zero blocks adjacent to each other, so then we can choose the maximum adjacent zero consecutive blocks, and we can represent it by a double colon like this. So now if we abbreviate this particular IP address, so we can write like this. That is, we can write 2001 colon 0, because the leading 3 zeros has been omitted, and it is represented by single zero. And 3238 as it is, we can write, and then colon. And this block also we can write as it is, DFE1. And already the leading zeros we have omitted, so therefore we take 63. And these two consecutive zero blocks can be represented by a double colon and the remaining block FEFB, right? So this is the second rule application, and the address has been compressed more than this here, right? So therefore, this is the two rules that we are using to compress the address and simplify it. So first one is discarding leading zero, and second one is representing the consecutive zero blocks which are contains zeros, and omit them all and replace with the double colon sign. So these are the two rules that you have to keep in mind. So, and also we do another thing in unicast address schemes, that is the second half of the address is always 64 bits, because you know that this address is made up of 128 bits. The first 64 bits block is utilizing for recognition of a network and subnet, and the remaining 64 bits are utilized for the interface ID. That means the host part recognition. So therefore, the last 64 bits we can incorporate with the MAC address of any device to enhance the uniqueness of the address, right? So the MAC address of a system is composed of 48 bits and represent in hexadecimal. So therefore, very easily we can utilize the MAC address to recognize the device uniquely. But since the last part of the IP version 6 address is consists of 64 bits, so we have to do some transplant. That is the MAC address we take from the device, and we what we do is we extend the a particular MAC address by adding or by doing a sandwich of two halves of the MAC address, that is FF EE block. That means I'll show you that how to do this, right? So this is the MAC address of a particular device, and it is a 48-bit address. So what we do is FE block we are transplant in between these two sites, because most of the time the MAC address is made up of two parts. One is to recognize the device manufacturer, and this number is given by the manufacturer who manufactured this device. So therefore, in between these two addresses, we can transplant or sandwich the block called FE block, and we can make it from 48 to 64. So this, after this type of operation, it is called after sandwich into those two halves of MAC address, the resulting EUI64 interface ID. That means extended unique identifier format. Extended unique identifier format. So the unique identification has been extended by incorporating the device MAC address and the FE block, right? So this is called, if somebody asks that what is extended unique identifier, so now you can explain how it has been become a unique extended unique identifier, right? So it is depending on the MAC address, right? So this is in detail. So if you're interested, you can go for that. And also I have to tell that there are different types of addresses under the IP version 6. So some of the addresses we have found that global unicast address and link local address. So likewise, so if you take local unicast address, this address type is equivalent to the IPv4's public address. The global unicast addresses in IP version 6 are globally identifiable. Why? Because it has a global routing prefix. So it is utilized to globally identify this address. And the subnet ID is there. That is 16 bits utilized for that. For global routing prefix, they utilize 48 bits, and the remaining interface ID is 64 bits. So this can be otherwise utilized as with this extended unique identifier. So therefore, it is possible that this part we can convert like that. And in global unicast address, the most significant 8 bits are designed as global routing prefix, which is assigned to specific autonomous system. Because you know that when it comes to the public IP addresses, the most of the time it is provided by the ISPs, internet service providers. So to recognize the internet service providers, they are assigned with a autonomous number by IANA, right? The global numbering governing body. You can search from the Google what is IANA. So this global routing prefix, which is assigned to specific autonomous system. So therefore, if the dialog has been given this global unicast address, so by the autonomous numbering has been given for them. So with that autonomous number, the public communication can be recognized each and every ISP by utilizing this autonomous number in a autonomous system. So the autonomous system means a particular network system which is under a single administration. So that is called autonomous system. The three most significant bits of the global routing prefix is always set to 001. So that is one of the main feature of global unicast address. The most of the time, the most significant bits are being set to 001, right? So this auto-configured address, that is a link local address, and this address always start with FE80, and 16 bits of link local address is always set to 1111110, right? So that is FE80, right? And the link local address are used for communication among IP version 6 host on a link only. These addresses are not routable, so the routers never forward these addresses outside the link. So that is what the link local address. And unique local address, all these addresses are unicast address. This type of IP version 6 address, which is though globally unique, but it should be used in local communication. So that's why it's called unique local addresses. These addresses has second half of interface ID, and first half is divided among prefix is always set to 111, 1110, 111, sorry, 110 L bit, which is set to 1 if the address is locally assigned. So for the meaning of L bit is the 0 is not defined. So therefore, the unique local IP version 6 address always start with FD prefix. So therefore, we can recognize unique local address with this starting blocks, and local bit and global ID and subnet ID is there. So you can see the structure. Unicast address, the prefix always set to 1111110, and there's a L bit which is set to 1 if the address is locally assigned. So far meaning of L bit is 0 is not defined. That means there is no 0 definition for L, but if the L is 1, so then it will recognize it as a locally assigned address, right? So therefore, unique local IP version 6 addresses always start with FT, right? So this is the address scope of link local addresses is limited to segment. Unique local addresses are though locally global, but are not routed over internet, to limiting their scope to an organization's boundary. So therefore, global unicast addresses are globally unique and recognizable. So they shall make the essence of the internet version 2 addressing. And the scope of link local address is limited to the segment. Unique local address are though locally global, but are not routed over internet. So the same thing I have repeated. These are the globally unique block allocation to regional registers. You know that there are many internet registries. Now for Sri Lanka, it is Asia Pacific region, and so therefore we belongs to that area. So likewise, for different regions, the IP address blocks are there for different IPs, ISPs. So these are some of the regional registries which are the organization who provide the IP address for different autonomous system in different countries. So you can see them, and for your information, you can search from the Google and find out more information on that, right? So for your information, I have explored this, right? So these are the practical implementation of aggregated IP addresses. That is for your information. So anyway, now you can understand that how the IP version 6 is differentiate from the IP version 4, right? And also I have another slide which is which will be showed to you. One of the exercise that is under the IP version 6 for subnetting. So that is we have been assigned 48 slash IP version 6 address. So this is the address block, and it is asking for create subnets for company ABC, and it has 3 main sites in London, Manchester, and Liverpool. The London site has 5 subnet subdepartments, and Manchester site has 8 subnet departments, and Liverpool site has 7 subnet departments. Right. So this is a case study. So you can refer this case study from this particular link. So let me see that I can copy the link, and I will put into the chat box. So then you can refer that that case study to understand how the IP version 6 thing is happening. Let me see. I'll paste it to the chat box. It is the very large fonts, so I'll have to do something to reduce it. Okay, now I think it's all right. Let me see. Right. And it is all right. Now you can refer it, right? So this is the it's a Cisco document about the case study of subnetting IP version 6 address. So you can see that example for your reference, right? And let's see. Yeah, the things I can show you about IP version 6. Yes, I'll show you the RFC of IP version 6 for your information. Please look at this. This document is request for comments 4291. This is the obsoletes of 3513 because it has upgraded to 4291. So that means more findings has been found by the scientists. So this is open to the public for their comments. You can see that there are a lot of information, right? The introduction is there, IP version 6 addressing models are there, how to represent the addresses, all the informations are there, and in detail, what are the unicast addresses, what are the multicast addresses, and how the INA consideration, security consideration, all these things are there. So if you do any research on IP version 6, so you can utilize this document and you can find out more information about the IP version 6 addressing, right? So, but then you can see that all the information related to the IP version 6 here. So I have, I will share these documents also. So then you can refer it. I believe in your, if it is not available in your drive, so I'll share it, right? And there are some other white papers also in internet. So that's also you can utilize to enhance your knowledge in this area. So I'll show you that. Sometimes you may not come across these things. This is IP version 6 addressing white paper. So these white papers also can be utilized for your enhancement of your knowledge. Right. So you can see that I will increase. So this is a global addressing because we have learned different types of addresses, right? global, unique local, and link local. So this is example for link local address. This unique local address, global address representation, and these are some of the unique global unique block allocation to the regional registries. So that is actually governed by Internet Assigned Numbers Authority, that is IANA. So these are some of the RFCs which I have showed you, and you can see that more information on that. And yes, these are the INA assigned regional registries, and different ISPs got different IP blocks from these registries, right? And when you are planning address, there are some advices that has been given by in this white paper, and if you go to the subnetting part, this IP version 6. So I can show you. This is one of the prefix breakdown. Sorry, and 16 bits for organizational subnets. Now see, this is the IP version 6 address, and it has abbreviated, and it is 48 bits. So this global prefix has been one of the octet has been one of the hexadecimal block has been utilized for subnetting. Here the first 4 bits, because if you take 1 bit of this, if you take 1 hexa digit of this, it can be represented by 4 bits, right? Because if you take 1 bit, its value is 16, right? So if you convert it into binary, it can be represented by 4 bits. So all these hexadecimal digits can be expanded to 4 bits blocks, right? 4-bit blocks. So here the one hexadecimal digit is 4-bit to define regional prefix they are utilizing. And another 4-bit define the site prefix, in which site this particular network is residing. Then this is this 4 bits for a particular subnet function, and this 4 bits also for subnet prefix, right? So you can see that here some of the regional prefix that has been assigned to recognize, and I will show you the subnetting. This is one of the bit that is to define regional infrastructure prefix, define site infrastructure prefix, and the site subnets, right? So that's how they have utilized this particular IP address. And also you can see that, right? I have discussed earlier. So I want to show you the subnetting part, right? That's why I'm going very quickly. Study. Show you. These are the some of the addresses, right? Regional, yes, the regional. It has been used in different block. For functions, it are using different blocks. The point-to-point segment, they are using different blocks. So likewise, they can utilize this particular block of hexadecimal block to send the different subnets of this vectors, right? So this always you have to think about that this block can be expanded by binary into 4-bit block. So that 4-bit will be represent the region, and this 4-bit represent the site, and this 4-bit represent a particular subnet, and this 4-bit represent a subnet prefix. And that's how it has been. So anyway, for the time being, you keep in mind like that, right? So that is one of the white paper which I have to show you. In addition to that, I will show you that so next time I will show you one of the example for subnetting. I don't know whether we have a subnet example with me. Ip version 6. Only I have Ip version 4, it seems. So next time I'll show you one of the example of Ip version 4. Right. Okay. So let's see whether I have a comment request for comments document to show you Ip version 6. So then how the subnetting has been done. I can show you. This one there. Okay, I'll share that screen, right? I'm sorry. Yes, I'll share my screen. Okay, so this is some of the features I want to highlight again. The following are the features of IP version 6 protocol. New header format is there, large address space, efficient and hierarchical addressing and routing infrastructure, stateless and stateful addressing configuration, built-in security, better support for quality of service, and new protocol for neighboring node interaction and extendability. So we look at, so this is the IPv4 and IPv6 differentiation. You can see that 7.7 into 10 to the power 8 addresses per person on the planet, right? And so you can understand how much addresses it can be generated. And this is the comparison of IPv4 and IPv6 headers. You can see that very complex header the IPv4 has, but IPv6 has very simplified header, and also it has next header. So therefore, we can add more headers to this IP version 6 header according to the requirement. So until you add additional headers, it is always maintaining very simple header format. So therefore, it's more simplified than IP version 4. So these are the some of the extension headers adding process. So you can see that IP version 6 packet is growing little by little while the adding any number of extension headers to the basic header, right? So these are the defining address representation. So we have gone through this, and this is the address format, and this is the two rules, right? And this is the case insensitivity, because it is not sensitive to the cases. And IP version 6 address types are there in this RFCs, right? These are the three types of addresses: unicast, like a single interface, anycast, and multicast. And these are the address types identification. You can identify the loopback address from this, link local from this block, multicast from this block, and global unicast everything else. IP version 6 address space. It was only released a portion of the IP version 6 address space for public addressing as per the RSP 2374. So if you are interested, you can refer these RFCs for more details. All valid IP version 6 host addresses begin with the hex state of 203, right? So this is the global unicast address, and these are the allocation of INA has allocated these numbers, the global prefix, and the extension extended unique identifier. I have explained it. Link local address I have explained, and auto configuration and how this sandwiching is happening. I also explained. These are the some of the multicast addresses for permanent multicast addresses, right? Multicast and IP version 6 mobility, and also the built-in security, that is IP6, right? So some of the configuration part, so I'm not going to explain here now, right? So earlier it was a few things when it transit to IPv4 to IPv6. So for example, you can see that if the host is running IPv6 and if the network is IP version 6 and if the public network is IP version 4, so there was some routers to convert the IP version 6 to IP version 4. So that's how the IP version 6 has been utilized early days before the total transition. So this is called a dual stack, right? IP version 6 and IP version 4 conversion, right? In tunneling also, they have used dual stack routers, right? So these are the main differences of IP version 4 and IP version 6. Okay. I think that's enough for the time being about IP version 6. So we probably we will able to start about devices. Before we start the devices, we see a small, let's see whether I have that.
Excuse me, sir. Are we getting any questions for the exam from the IP version 6?
Yes.
Okay.
That is actually under the IP addressing commonly it comes, right? So sometimes the question might ask according to the willingness of the student, they will give you a scenario and they will ask you to choose appropriate IP addressing scheme for the assignment. So there you have to know if you prefer IPv4, you can do it by IPv4. If you want to do it IPv6, so then you have to do it in IPv6. So that's how the questions come. And also sometimes if there is a mock exam online, some of the questions might ask in the mock exam also. For example, the two rules when you apply to a IP address, how this compression has been happened, and what are the different types of addresses available. For example, like unicast addresses and multicast and anycast they might ask. And also the recognition blocks. Now, for example, we have learned FE80 block, FEFC block, right? Those things we have learned.
Only from the theory part, right? Not any subnetting.
If it is going to give multi-choice question, that means quiz online, some of the parts in the IPv version 6 might ask, because it has been in the syllabus now. That's why they will ask those short questions. But in an implementation like environment, for example, let's say you have to do a particular test cases for a particular scenario. So there you can either use IPv4 and IPv6. Sometimes if they ask to do the practical in utilizing both IPs, that is IP version 4, IP version 6. So you have to show them in both IP addressing schemes. So that's how it's happened. Okay, to recognize device, we will see this as small video to recognize different network devices. So let me see whether I can share with you. Can you see my screen to everybody? Hello, can you see my screen?
Yes, sir.
Yes, sir.
Okay.
Yes.
So I'll play this small video. So then I will try to recognize different network devices and their capabilities and how they are functioning, right? To get a small idea.
In this video, we're going to talk about the difference between a hub, a switch, and a router. Now, all three of these devices are similar, but there is a difference in the way they handle data. So we'll first talk about a hub. Now, the purpose of a hub is to connect all of your network devices together on an internal network. It's a device that has multiple ports that accepts Ethernet connections from network devices. Now, a hub is considered not to be intelligent because it does not filter any data or has any intelligence as to where the data is supposed to be sent. And that's because the only thing a hub knows is when a device is connected to one of its ports. So when a data packet arrives at one of the ports, it is copied to all of the other ports. So all the devices on that hub sees that data packet. So again, a data packet comes into one port, then the hub will just rebroadcast that data to every port that has a device connected to it. So even if this computer here only wanted to communicate with this computer over here, these other computers would still receive the data even though the data was not intended for them. So when this happens, it not only creates security concerns, but it also creates unnecessary traffic on the network, which wastes bandwidth. Now, a switch is very similar to a hub. It's also a device that has multiple ports that accepts Ethernet connections from network devices. But unlike a hub, a switch is intelligent. A switch can actually learn the physical addresses of the devices that are connected to it, and it stores these physical addresses, called MAC addresses, in its table. So when a data packet is sent to a switch, it's only directed to the intended destination port, unlike a hub where a hub would just rebroadcast the data to every port. So as an example, if this computer here wanted to communicate with this computer over here, the data packet arrives at the switch, and then the switch will look at its table of MAC addresses and matching ports and deliver the data to the correct port. And then the data packet would only go to that computer. So that's the major difference between a hub and a switch. So as a result, switches are far more preferred over hubs because they reduce any unnecessary traffic on the network. So as a review, a hub only detects that a device is physically connected to it, and a switch can detect specific devices that are connected to it because it keeps a record of the MAC addresses of those devices. Now, hubs and switches are used to exchange data within a local area network. For example, such as in your home network or in a business. They are not used to exchange data outside their own network, such as out on the internet. Because to exchange or route data outside their own network to another network, such as out on the internet, a device needs to be able to read IP addresses. And hubs and switches do not read IP addresses. So that's where the router comes in. Now, a router does exactly what its name implies. A router is a device that routes or forwards data from one network to another based on their IP address. When a data packet is received from the The router inspects the data's IP address and determines if the packet was meant for its own network or if it's meant for another network. If the router determines that the data packet is meant for its own network, it receives it. But if it's not meant for its own network, it sends it off to another network. So a router is essentially the gateway of a network. So here we have a private network with its router, and we'll refer to this as the red network, indicated by the red colored screens on the computers. And over here, you're going to have different data packets, indicated by their different colors, which represents different IP addresses, and they are going to be entering the red network's router from the internet. Now the router is only going to accept the red data packets because they are the only ones that are intended for this network. So all of the other data packets, the yellows, blues, greens, etc., will be rejected by this router because they were not intended for this network because their IP addresses were not meant for this network. Now here is an expanded view of routers over the internet. There are 4 networks here, indicated by their different colors, and each network has their own router, along with their hubs or switches and their computers. So right now, as you can see, each network is just exchanging information within their own network. Their data is not going out on the internet, so they are not communicating with other networks. They are just exchanging data within their own network using their hub or switch. Now let's go ahead and exchange data between different networks. So let's say, for example, that this computer here on the red network wants to communicate with a computer here on the blue network. So for this to happen, the data packet has to leave their own network and go out on the internet. So the computer sends their data, and it goes to the network's router. And once the data packet reaches the router will look at the IP address of the data packet and then forward the data out on the internet to the next router, and then make its way to the blue network's router, and then to the intended destination computer. So in a nutshell, this is how routers work. So in conclusion, hubs and switches are used to create networks, while routers are used to connect networks.
So I believe that you have gotten some idea about switches, routers, and hubs. So hub is not very intelligent device, and according to this video, it says that it's always except the receiving port, all the other ports will be send this information. So because of that, it has a traffic creation problem. So therefore, that's why most of the time the networks you can't find hubs very frequently. But when it comes to the switches, you can see that in hub the data going through every ports, right? But in switch, not like that. It is using a MAC table. In switch table, it's called MAC table. MAC addresses are there. All the devices are uniquely identified. And when information received by the switch, it is detect the desired destination, and it will direct or forward this information to the particular device. It is not sending all this information through all the ports which are connected to the other devices. So this is therefore we consider it somehow intelligent to a certain extent than the hub. But anyway, all these devices are functioning in the layer 2 according to the OSI model, because we have learned the OSI model. So according to the OSI model and also the TCP/IP model, these devices are functioning in the layer 2. That means data link and the physical layer. So therefore, these devices are belongs to, that means the switch actually belongs to data link layer, and these devices are called layer 2 device. But hub is a not a layer 2 device, it is layer 1 device. It is just forwarding, receiving signals and forwarding the signals. There is no any intelligence. But anyway, these both of these devices are creating networks, and they are contributing to create networks in the networking environment. But when it comes to the routers, routers are doing different job. Actually, they are connecting different networks together, because switches can't connect the other networks, and they can't read actually the IP addresses. So therefore, the switches they cannot do the exchange data outside their networks, right? But to exchange the data outside their own network, a device needs to be able to read the IP addresses. So that ability is only having the router. So therefore, router is a device which is connecting the networks, right? That's why it says. So routers routes data from one network to another based on their IP addresses. So therefore, the interconnectivity between the networks is done by routers. So as a result of this functionality, we can say that the internet is also a collection of routers. So if the routers were not there in the internet, so you will not be able to use the internet like today, right? So therefore, the router contribution to the internet is very high number. And also it's playing a very vital role in the internet. So IP router has a IP table, and it is always check the source address as well as the destination address, and accordingly he will or the router will direct or the route the traffic to the desired network according to the IP address, right? So these are the few things that we have captured from this video, and then I think you could understand how this the routing has been happened, and how these different networks are being connected. And finally, we understood that the hubs and switches are used to create networks, and the routers are contributing to connect the different networks. So that's what I want to highlight you by this video, right? So that is what we have to learn from this video. So in a switch, in the sense, switch is capable of creating networks. So we can connect devices to the switches, and we can share the resources and what you call do the communication in between different nodes. So therefore, whenever you want to establish a local area network, so you have to go for a switch according to the requirement, because if you take a switch has different number of ports. Some switches are 8 ports, some switches have 16 ports, some switches have 24, and some switches have 48 ports. So likewise, according to the number of ports that are available in a switch, the size of the switch will be varied. And also we can divide the switches into two types now in a practical environment. data switch and the PoE switch, right? The power over Ethernet switch, right? Now, if you want to establish IP, voice over IP connectivity in a network, so you have to use power over Ethernet switch, that is we call PoE switch, right? So if you want to provide data links, data points, that means to communicate in between devices, so then as only a data switch is enough. PoE switch is not required. But if you have a PoE switch, you can have both data communication as well as the voice communication. So therefore, according to the requirement, when you are designing a network, you have to decide whether you are going to incorporate data switch or whether you are going to incorporate PoE switch, right? So the cost also vary. So therefore, when you concern the cost also, so you have to consider these things, and you have to understand that what is the appropriate switch or you have to choose, right? And also sometimes these switches are stackable. That means we can connect one or two or three switches together, and we can use it as a one switch. So when you are ordering or when you are preparing a specification for a switch, so you have to consider these things. Sometimes you are wasting your money, because if there is no any requirement to connect them or stackable them, or if you don't need to stack them one over the other, so no need to have a stackability features for the cables, because it will be costly. And also if you have a backbone, that means if you have a core switches, that means core switch means they are capable of functioning in layer 2 as well as layer 3. That means some switches have this capability because they have a routing capability also. Switching, in addition to the switching capability, they have routing capability. That means they can connect different networks, and also they can create networks also. So therefore, these devices, they are function on both layers, that is layer 2 as well as layer 3. So that's why these switches are called core switches. So when we connect these switches together, most of the time the devices will be connected through twisted or the copper cables media. But when these switches are functioning in flow levels in a building, and when they connected together flow wise, so there should be a backbone, and these backbone cables will be plugged into the core switches. So there you have to use fibers, because why? Because it is containing aggregated traffic from flow level, and it should be transferred to the core switches, and then it's aggregate to a WAN link, and then it goes to the public through a public line, and it goes to the outside. So that's how the network is, the connectivity. So therefore, there we have to have STP modules to connect the fibers to the core switches and flow switches. So whenever you are preparing a specification, so you have to know that these features also are needed in a switch that you're going to order for purchasing. So therefore, to get a good idea about these switches, better to visit the sites like cisco.com and hp.com, Juniper, and there are Dell. All these switches are available in different features. So to get an idea in the industry how these switches features are varied, and how their capabilities, what are the data transfer speed of these switches. Some switches forward data in 1 gig, 1 gigabit per second. Some are in 100 gigabits per second. So nowadays, most of the switch series starts from 9,200, but early days it was 2,400 likewise. So therefore, the new features, if you want to know, so better to go for a vendor switch vendor website, and you have to look at what are the latest product that they have, and some of the vendors, they have integrated these features to one device, and they try to minimize the cost of the infrastructure of a network. So all these things can be addressed by referring to a vendors website like Cisco, HP, Dell, Juniper, likewise, right? So these are some of the things that I have to highlight in with respect to the switches. So you should know that these switches are capable of mainly functioning layer 2 as well as the layer 3. And also when we do networking, we should know the structured cabling techniques also. There you have to know that you can't directly connect a switch to a device. So when this particular link is coming from the device will connect to a wall outlet, and the wall outlet is consist with keystone. That keystone is connected with the copper cable. The copper cable might be, as we learned earlier, it might be STP or a UTP cable. So that cable is end up with a patch panel, right? The patch panel will be connect to the switch through a patch cable. So they never directly connect with each other. These devices. Excuse me for a minute. Right, excuse me, right? So anyway, so this is where that we have to concern that the structured cabling. So as I said, the patch panels, the patch codes, fly codes. Fly code means the from wall outlet to the computer. So this is called actually the horizontal cabling. And some of the telecommunication closets you can find, that means we have to mount these switches to the walls, and sometimes we bring these switches to the racks if you have multiple switches. Sometimes it might be floor level switches, floor level switch racks, and then it goes to the server room for core switch level racks, right? So that is how the network setup is. So then when it comes to the routers always functioning in layer 3. That is, they are forwarding packets. The switches, most of the time, if they function in layer 2, they are forwarding frames, data frames, because we have learned all these things in the reference model, open reference model, and also the TCP/IP model. How this protocol data units are behave in different layers. How the segments comes, how the packets come, how the frames comes, all these things we have discussed. So therefore now you should able to remember that. So how when a communication taking place in a network like this, how it is happening. So until the switch, the frames are communicating, do the communication. So that is called Ethernet technology. So then after that, when it comes to the router level, so it is doing by the protocol data unit is the packet, and they are functioning in the layer 3. So they are keeping IP tables, and they are directing the appropriate traffics to the each and every network by connecting each networks together. So that's how the connectivity is happening. So in switching, there are different types of switching methods are there. And when it comes to the routing also, there are different types of routing also there, right? So we'll discuss them later. Switching, there are different switching. When it comes to the routing, routing can be divided into different types, static routing and dynamic routing. Dynamic routing, we can divide it into two types, that is distance vector and link state routing, right? So that is how the routing is happening. So all these things we have to discuss in details in the future, right? So in your assignment, in the sense, have you got the assignment from London Tech, or still you didn't receive?
No, I think it's still not, we didn't receive.
Still you didn't receive? Did you made any request?
No, we didn't make any requests because we have already too much assignments.
Very good student. Actually, you are very honest, right? Because very rarely they openly speaking. Okay. Anyway, you get the advantage of the delay, right? And finish it off all the assignment that you have already received, and vacant the time for this assignment, right? So otherwise, don't keep the all the assignments also to do with this assignment. So the time will be not enough for you, right? So most probably,
Okay.
most probably the assignment would be coming from routing area, and it might be the last time it was about a new routing protocol they were discussing, they were asking. So therefore, you have to learn the routing thoroughly by concentrating on that. So therefore, so better to don't miss the lectures. You doing coming weeks, and if we had the assignment, we could focus the assignment also, and we could do the lectures. That's why I asked the assignment. Anyway, I also requested from London Tech, but still they didn't signal that which is the assignment that we have to do. Okay, if they say that the same assignment we have to continue as the last year, so it would be better, so we can do it. Otherwise, if they give a new assignment, so we should know it very early and adapted to it and do the lectures accordingly. Because ultimately your object is your target is to pass the assignment and get a good result. So when we see with that intention, if the assignment is available, it's good to have an idea and do the lectures as well, right? So we'll try to explore some some background about routing. So therefore, I have a presentation with me. So can you see my presentation?
Yes, sir.
Okay. So if somebody has no idea about routing, so simply we can see this picture. to understand the routing table, because it's a view of routing table. The routing tables are used by network devices in order to determine where a packet should be sent in and attempt to get it routed to its final destination. So that is the simplest definition that we can give when somebody asks what is routing means, right? Routing means there's a routing table, and this routing table is used by the network devices. Why they use this routing table? In order to determine where a packet should be sent in an attempt to get it routed to its destination. So that is the main purpose of having a concept called routing, right? Because earlier video also we have seen that if you want to connect different networks together, the right device is the rightmost device is the router, right? So in that sense, we try to understand this routing. These are some of the routing tables. As you can see that the destination addresses you can find, net mask is there because they are interact with IP packets. So then definitely they are interact with IP addresses and the gateway addresses, because whenever they receive a IP packet, it should be directed to another network sometimes. So they are from the existing network to go out to the another network, there should be a gateway, as you asked a question earlier. So all these things are in interfaces, and with the interfaces, and sometimes it is showing the metrics. That means to go to the destination, how many hops that you have to pass, or hops means how many routers that you have to pass. So likewise, that kind of information you can see. So as I said earlier, the routing can be divided into two main parts. One is called static routing, and the other one is called dynamic routing. So in a static routing, all the routers have to have their routing table configured and updated manually. So it will not happen automatically. We have to configure the routers, their routing tables, and we have to update them manually. But in dynamic routing, it is entirely different. The routers communicate with each other to share their routing information with each other. So it is happening dynamically, that means automatically. So actually in a internet-like environment, if this has been happened in a static way, so you can imagine that how complex it is and how difficult it is. But most of the time, with the help of this dynamic routing, the internet is behaving by himself without giving much bother to the human beings, right? So to get an idea about the router's function, so you can think this is a router, and his characteristic is like this. He's always try to search about his neighbors, right? He's always seeking gossips, right? And try to understand who are the people around him, right? So that's why he says that I am attached to a network A over here and network B over here. So the router says that who are the neighbors of him to the others. So then others will come to know that who are the neighbors of them. So likewise, how he aware about himself as well as the neighbors around him, right? So all these information will be updated in a table. So that table is we call IP table. So this is the IP table he maintained. So he recognized two networks are there in between in either side of him. So then he update all the information related to them. So here there's another router. He also like same way reacting. I not only know about the network A, but other side of me is connected to network C. So likewise, they are sharing their information, and they utilize this information to send data packets from one source to another destination. So see that how these tables are updated with the information, with the neighbors information, and how many hops are there. All these things are updated gradually when they are communicating with each other like this, right? So you can see that how this communication taking place and how that IP tables are updated accordingly. So because of this knowledge, whenever IP packet reach a router, so is capable of directing this packet to the correct destination with a minimum amount of, with passing minimum amount of hops, right? Hops mean number of routers, right? So likewise, you can see that how these IP tables are updated gradually one by one, and ultimately they are saturated with this information. So then it will be more convenient for them in communicating with each other, and they will never do any mistakes when forwarding this packet information to their desired destination, right? So this is simply what how we can explain how these routers are working together and work on together and do the information route to the direct correct destination. So routing protocols, the dynamic routing protocols, we can divide it into two types. That is distance vector routing and link state routing. Each router communicates under the distance vector routing. Each router communicates all the networks it knows about to the other routers to which it is directly attached, and the communication takes place on a regular basis. So these are some of the differences that we have to realize very clearly to understand the differentiation in between the different routing methods. Because if you think about a new routing protocol, sometimes the advantages and the disadvantages of the available routing protocols or the routing methods we have to know. So based on those knowledge only, we can think about a new routing protocol which we can propose, which is get rid of all these drawbacks from the existing routing protocols, right? So therefore, if you look at the distance vector routing, each router communicates all the networks it knows about to other routers to which it is directly attached, right? And communication taking place on a regular basis, right? So now you know the nature of a router. Please always communicate with the routers, communicate all the networks it knows about. All the networks will communicate, and also the routers which is directly attached, and communication take place on a regular basis, right? In link state, how it is happen? Each routers build a map of entire network. Now, so this kind of a thing not happening in distance vector, right? Is directly attached networks only he knows. But in link state routing protocol, each routers build up a map of entire network. So that means he doesn't want to communicate in regular basis. Why? Because initially, in initial stage, he map the entire network he attached to, and he keep the information with him. So then he's doing a very nice mechanism. So that is called link state advertisement, right? LAS. They use this link state advertisement to communicate information about networks they are connected to the communication only take place. So this is the beauty, right? The communication only take place when a change has been made. So by looking at that particular statement, so we can understand that with respect to the distance vector routing, so these routing protocols are not communicate regularly. Once it's happen any changes to the network for the existing setup only, they will communicate by sending a link state advertisement to the entire network. So because of that, the generation of unnecessary traffic for communication within the network will be reduced to a considerable level, and therefore the efficiency of routing also very high with respect to the distance vector routing, because in the distance vector routing this communication is taking place in regular basis, right? So these are some of the distance vector routing protocols. Actually, they are dynamic routing protocols in other way. One of the distance vector routing protocol is the RIP or the routing information protocol. Now you don't forget that these distance vector routing protocols have common features. That means in the earlier also we have gone through that they have regular updates. Now, if you take a distance vector routing protocol, all the protocols have this common characteristics. They have regular updates. Whether you take a RIP or RIP version 2 or a BGP, they all have this common characteristic. That means they have a regular basis updates. So because of that, the traffic generation is higher with respect to the link state routing protocols, right? So in RIP, the maximum hop count is 15. That means they can keep knowing about only 15 neighbors actually. 15 neighbors, that means 15 neighbors mean 15 routers. If you use a RIP version or distance vector routing protocol like RIP, so they can only manage 15 hops at once. So more than that, they can't keep information. That is the restriction, or that is the limitation they have. And originally had updates sent every 30 seconds. So now you can understand how frequently it is updated their routing tables or information of each of the router. So because of this, high traffic will be generated. And it does not support authentication. That means the security is very low, and it uses only the broadcast communication. So broadcast communication is not a very efficient communication system, because it send this information to every node. So because of that, high traffic will be generated. And the RIP version 2, it also has this common features like 15 hops only he can keep in mind, and the supports the authentication actually, not like RIP version 1, and uses the multicast communication. Now it is better than the broadcast communication because it's only communicate with a specific number of nodes, which is predetermined, not with everybody, right? And BGP is the border gateway protocol. It's the core routing protocol of the internet, typically used by the internet service providers. That means actually this border gateway protocol is established in between the autonomous systems, right? Earlier we found that name, that word, autonomous system. Autonomous system is a system which is under a single administration. Now, for example, if I say one of the ISP is the SLT Mobitel, and another ISP is the Dialog, or another ISP is the Airtel. So these all these communication companies have ISP companies, and they have an autonomous system. So these all in between those autonomous systems, they are using this border gateway protocol, right? And if you look at the link state protocols, that is under the dynamic routing protocol, there are two types. One is distance vector. Now earlier we have seen different routing protocols under the distance vector routing protocol. Now this is link state routing protocols under the link state routing protocol. There are two types, that is OSPF and ISIS. The OSPF means the open shortest path first. They are using they used algorithm, and they most of the time they are using this particular routing protocol for medium to large networks, and bases its path of link states, and can also use cost metrics to give reference to certain paths. So because of that, it is very efficient. Very efficient routing protocol, because it's always try to calculate the shortest path first, and then after that they forward the packets to the destination by according to the selected shortest path. And intermediate system to intermediate system, so that is another link state routing protocol. It's a intermediate system is another name for a route actually, and it's originally designed with the OSI model, but it is not very rarely it is used. It is not frequently used link state protocol. And there are some hybrid protocols also. That means we can find the characteristic of distance vector routing protocol as well as the link state routing protocol. So because of these common features of two main routing protocols, two main dynamic routing protocols, so it is known as a hybrid routing protocol. So it is actually known as enhanced interior gateway routing protocol. It was actually evolved from interior gateway routing protocol. It is a distance vector routing protocol, and it's used the diffusing update algorithm. Diffusing update algorithm. So it has certain metrics to measure, and then after that it's calculating the paths to the destination. So each router keeps a copy of its neighbor's routing tables, and each router periodically send out a hello packet, just like link state advertisement. So it is not update their IP tables in a regular basis. So because of that, it's slightly different from the distance vector routing protocols. And also it is very closer to link state routing protocol. Why? Just like link state advertisement, these routers also periodically send out hello packets to keep track of the state of its neighbors routers. So these are the some of the things that about the hybrid routing protocols. And we come to a very important topic, that is convergence. So when we are discussing about the routers, we found that the routers do, some routers are updating their router table information regular basis. Some routers initially map the entire network, and then after that, whenever change occur, only they update their routing tables. So for all these purposes, a considerable amount of time will be required. So this time that it has been taken by the routers to acknowledge or aware about their neighbors' routers or the networks is called the convergence time. So when the changes are made to a network, every router on the network will need to make an appropriate changes to their routing table. So in order to accommodate the changes. So this could be addition or deletion of a router, or could simply be a change in a metrics for a particular path. So the convergence is the process of all routers becoming aware of the changes to the network. So that is what the convergence means. So if a particular network is taking a particular time for the convergence, so that is called a convergence time, right? So for the time being, we'll look at these two protocols also. That is there are two main types of protocols we can see. Now, if a particular protocols are running only under a single administration or within an autonomous system, so those routing protocols come under the interior gateway routing protocols, right? If a particular routing protocol functioning in between two autonomous systems or in between autonomous systems, those routing protocols we call EGP, that is exterior gateway protocols. So for interior gateway protocol, the examples are RIP version 2, IGRP, OSPF, and also ISIS we can take. But for EGRP, there is only the routing protocol that we can take as an example is the BGP, that is border gateway routing protocol. Those are exterior gateway protocols. Others which I have mentioned are interior gateway routing protocols. So I think now you can understand how to explain what is a routing table, and you know how to read one, and I have explained the difference between the static and dynamic routing, and also you are capable of describing the difference between the distance and distance vector routing protocols. And also you can explain the difference between the interior and exterior routing protocols. And most of the terminologies that you have found, that is what is autonomous system, what is static routing, what is dynamic routing, what is distance vector, what is link state. So all these things are we have discussed, and better to put a classification somewhere in your notes how these categorizations are coming. So then you have a clear idea about it and how these some of the routers have common, what are the common characteristics they have, and what are the individual characteristics they have. So all these things are important when you're doing the assignments, and also sometimes when you're doing online quiz also, right? So that is what for today I'll do. So next time I didn't get any break even because I started very lately. So I utilized the full time for the lecture. So thank you very much for being with me for a long time. Sometimes I didn't consider the common requirements also. We were keeping discussing everything for a long time. Anyway, thank you very much, and we will meet again on tomorrow morning. I hopefully believe that you will join again on tomorrow morning from 8:30, right? So if you have any questions, you can ask the questions tomorrow morning, and so then we will discuss them also, and then we can proceed from there. So thank you very much for being with me for a long time. Right. See you on tomorrow morning. Okay. Thank you.